so the next thing that we're going to start covering is asymptotes of rational functions. So a rational function is a function that can be written in the form of p of x over q of x, where p of x and q of x are polynomials, but q of x cannot equal 0. So whenever you have a 0 in the denominator, that makes your function undefined, okay? So in general, the domain of a rational function includes all real numbers except the x values which make the denominator equal to 0. So these first ones are asking us to find the domain of each of the following rational functions. So here we need to figure out what number for x would make that denominator equal to 0. Okay, so what we're going to do is we're going to go ahead and take x minus 3. Now, if you can figure out by looking at it what number is going to make that 0, you go ahead and set it equal to 0, and then solve for x plus 3 plus 3. That means when x is equal to 3, our function is going to be undefined. So when we write our domain, that's what they're asking us for, is the domain. I'm going to go ahead and write in an interval notation. So it goes from negative infinity all the way up to 3, and it doesn't touch at 3. So I'm going to put a little parentheses, okay? And then I'm going to put a u. It'll continue at 3. Now it doesn't touch 3, but then it'll continue all the way to infinity. Okay, and that's it. All right, this next one. So here we have x squared minus 5x. To figure out what values for x would make this 0, we first have to factor. So I'm going to go ahead and factor this. We'll take out an x, and we're left with x minus 5. Okay, so when you factor first, not only do you have to set the first term equal to 0, so x equal to 0, you also have to set the x minus 5 equal to 0. Okay? And so this one's going to have 2 places. Now this one, when x equals 0, that's going to make it undefined. And this one, we do have to solve for x. So plus 5, that means x equals 5. So that is the other part where it is going to be undefined. So for a domain, okay, you have to think kind of like a number line here. It goes from negative infinity, 0 comes first, and then we have 5 here. So you're going to have undefined here, okay? Your graph is not going to touch at those numbers. So we go from negative infinity to 0. So our domain will be negative infinity to 0. It doesn't touch negative infinity, it doesn't touch 0. Then you make a u, and then it's going to go from 0 to 5. So from 0 to 5, it doesn't touch, remember, because that's what's going to make it undefined. And then we put, I'm going to have to scoot over a little bit. We'll put another u. And then it goes from 5, and it'll continue on to positive infinity. So from 5, it'll continue to infinity. So by putting these little parentheses here, that tells you that it gets really close to 5, but it doesn't touch it because it's going to be undefined there. And that's it. Okay, the next one. Here we have 6x, x squared plus x minus 12. So on the top, we're going to put a 6x. That stays the same. We're going to factor the denominator. So when we factor the denominator, it is x times x gives you x squared. We're looking for 2 numbers that multiply to give us 12, but we'll add up to x. So 4 times 3 gives you 12. It needs to add up to a positive x, so that means that the 3 has to be negative. Okay. Then we're going to set both of these factors equal to 0. So x plus 4 equals 0, and x minus 3 equals 0. So we get x equals negative 4. And here, when we add the 3 to both sides, we get x equals positive 3. Okay. Then from there, we're going to go ahead and, write our intervals. So remember, we're going to think of a number line. Okay. Here would be negative 4. Here would be a positive 3. And then this is infinity. And then this is negative infinity. So when we write our intervals for our domain, it goes from negative infinity to negative 4. It touches negative 4, but doesn't cross it. And then it continues at negative 4 all the way to 3. We'll have a gap right there at 3. And then it'll continue from 3 all the way to infinity. And this would be our domain. Okay, and the last one. So here we have 8x squared minus 10x minus 3. So this one we're going to have to factor. I'm going to go ahead and factor this by grouping so the top stays the same. We multiply 8 times 3 gives me 24, so I'm looking for two numbers that'll multiply to give me 24, but will add up to 10. And this is minus 3, so let's see. 6 times 4, but, oh no, yeah, this gives you 24. 6 times 4 gives us 24, but it's not going to add up to negative 10 because one of them has to be negative and the other one positive. 8 times 3, 12 times 2. There you go. So negative 12 and a positive 2. Oh, I forgot to put the x in there. Okay, so negative 12 times a positive 2 would give you that negative 24. Sorry, I didn't put a negative there. But when you add them together, it's going to give you a negative 10. Okay. We couldn't use 6 and 4 because both of them would have to be negative in order for us to get a negative 10. A negative 6 times negative 4 would give you a positive 24, and we needed this negative 24. Okay. Once we do that, we go ahead and factor by grouping. So I group the first two and I group the last two. So this stays the same. Between the 8x squared and the 12x, we can factor out a 4x. And then we're left with 2x minus 3. And then plus 2x minus 3. And then our last step to factor this by grouping is to, we have the 2x plus 3 in common. So 2x, minus 3, sorry. And then we're left with 4x. The plus sign, remember, if there's no number here in the front, it is an invisible one. Okay, so those are my two factors. Those are the two that I need to set equal to 0 and solve for x. Okay, so here we add the 3 plus 3. We get 2x equals 3. We divide by 2. And we get x equals 3 over 2. Here we subtract the 1. And we get 4x equals negative 1. We divide by 4. And x equals negative 1, 4. Okay, so these are the two numbers that will make your equation undefined. So then for our domain, we are going to go from 0, no, not 0, sorry, from negative infinity to negative 1, 4. And then u from negative 1, 4 to 3 halves. And then another u from 3 halves all the way to positive infinity. And that's it. Okay, so here it says identify the domain of f of x equals x minus 1, x plus 2. So for our domain here, our x cannot equal, so if we put x minus 1 equal to 0 and x plus 2 equal to 0 and we solve for x, we would add the 1 here, add the 1 here, that would give us x equals 1. Okay, we subtract the 2 here, subtract the 2 here. That means that x equals negative 2, that's what's going to give us 0. So when for our domain, it's going to go from negative infinity to negative 2. Then we're going to have a little gap. Then it's going to go from negative 2 to 1. And then we're going to have a little gap again. And then we're going to go from 1 all the way up to infinity. Okay. So here it says a graph of f of x equals, and they give us a function is shown below, at which values of x is a graph breaking. So remember how here it says it goes from negative infinity to negative 2. So here's negative infinity to negative 2. You're going to see your graph is just going about its way, and all of a sudden it sees negative 2 and it avoids it. It shoots down. Okay? And then you have this other little section in the graph. So from negative 2 to positive 1, if you notice here, from negative 2 to positive 1, your graph is coming down along this way. Okay, it doesn't cross over negative 2. And then it starts moving a little bit to 1, and then it gets close to 1, and then it shoots down. It avoids it. Okay. And then here, the last section, we have from 1 to infinity. So it starts here at 1, okay? It looks like it touches 1, but it doesn't. It avoids it. And then it just goes about its way forever in the direction, okay? So if you notice, there's these points in the graph that it is avoiding. And these points are considered, or these are called asymptotes. Okay, you'll see an asymptote at x equals 1 and x equals -2. So here's -2, and here is 1. Okay, these are imaginary lines or invisible lines that your graph avoids. Okay, they will not cross them. So here, an asymptote is an imaginary line that the curve of a function. Oh, sorry. The curve of a function gets very close to or approaches. Okay. Now you can have, these are considered vertical asymptotes. You can also have horizontal or slanted asymptotes. But what we're going to work with today are just vertical and horizontal. Okay. So rational functions will have vertical asymptotes at the x values that make the denominator equal to 0. So here it says graph the vertical asymptotes. I did it already in those yellow lines. Write the equations of the vertical asymptotes. So we did that earlier. Our vertical asymptotes are at x equals -2 and at x equals 1. Okay? All right, horizontal asymptotes. Now you found your horizontal asymptotes different. You have 3 possibilities, okay? It says to determine if the degree of a function has a horizontal asymptote, we must compare the degree of the numerator with the degree of the denominator. Okay? So it'll make a little more sense with the examples. But here, if the degree of the numerator is equal to the degree of the denominator, and if you don't remember, you look at the exponents of x. I should do this in a different color. Okay, so you look at the exponents, the highest exponent at the top, so the exponent here is 1, the exponent here is 1, they're equal, okay? So if they're equal, the way that you find the equation is by taking the leading coefficients of the numerator and dividing it by the leading coefficient of the denominator. So for example, here, the degree of the numerator is 1, the degree of the the denominator is 1. Your horizontal asymptote, we have to look at the coefficient. So my coefficient here is 2. My coefficient of this x is 1. So we will do 2 over 1, which is just 2. So it is going to be y equals 2. Okay. Now you have the possibility here where the degree of the numerator is less than the degree of the denominator. Okay. Then that means you're going to have a horizontal asymptote at y equals 0. So if we look at this example, the degree of the numerator is going to be 0 because you don't have any x's to any powers. And then the degree of the denominator is 2. So 0 is less than 2. Okay. So because the numerator is less than the denominator, you're going to have a horizontal asymptote at y equals 0. Okay. And then the last example here, when the degree of the numerator is greater than the degree of the denominator, then you're not going to have any horizontal asymptotes. Okay, so if we look here, the degree of the numerator here is 2, and the degree, the exponent of x on the bottom is 1, and we know that 2 is less than 1. So for horizontal asymptotes here, we have none. Alrighty, so if we look here for the horizontal asymptotes, I'm just going to draw them in. We said it was at y equals 2, so here's my y-axis. Here's 2. We make a horizontal line going across. And you can see that your graph follows these lines, and it doesn't cross it. Okay. Here it says 0 is less than 2, so we had a horizontal asymptote at y equals 0. You're going to see that your graph follows along this line. Now your horizontal asymptote, some may cross it, so you might have an example where it does cross. Don't worry, that's not a big red flag, but they will follow along these lines. It's like a little guide for them. Okay. And then the last one, you can notice that there's no horizontal line that I can draw here. It will create or that the graphs will follow. Okay, there's no horizontal line, so that's why we have none. As a matter of fact, this one has a slant asymptote, and you can see it kind of follows this little imaginary line. But that will be for the next lesson, okay? All right, here it says complete the information for each function. Okay, so here they want us to put the domain, the vertical asymptotes, and then find the horizontal asymptote by finding the degree. So I'm going to start with the horizontal because I feel like that's the easiest. It's the least amount of work. Okay, the degree of the numerator, the exponent for x on the top is 1. The exponent for x on the bottom is 2. Well, 1 is less than 2. Okay, so if you don't remember this, you can refer back to your little chart here. Well, when it's less than, that means we have a horizontal asymptote at y equals 0. So horizontal asymptote at y equals 0. Okay, to find the domain and the vertical asymptotes, we do have to factor the denominator. So x plus 1. The denominator is going to factor as x times x gives you x squared, 3 times 3 gives you negative 9, 1 is going to be plus, 1 is going to be minus. That means that for your vertical asymptotes, you're going to have a vertical asymptote at x equals positive 3 and x equals negative 3. Okay, how did I get that? Well, I set x minus 3 equal to 0. I added the 3, and that means x equals 3. I said the x plus 3 equal to 0, and we solve for x, and we get x equal to negative 3. Okay, so that's how I found those two vertical asymptotes. Then for your domain, we write it as it goes from negative infinity all the way up to negative 3. And we have a little gap. It begins back up, and we have a little section between negative 3 and positive 3. Then we gap, and then it goes from 3 all the way to infinity. And that's it. Okay, let's look at the next one. So on here, I'm going to start at the horizontal again because I feel like that's the easiest. The highest exponent of the numerator, the degree, is 2. The highest exponent in the denominator is 2 as well. So when 2 equals 2, you have to look at the leading coefficients, which is a 5 and the 2. So then that means that we have a horizontal asymptote at y equals 5 over 2, which is the same thing as 2.5. All right, now the vertical asymptote. So to find the vertical asymptotes, we do have to factor the denominator. I can factor out a 2, and I'm left with x squared minus 4. And I'm not done factoring just yet. I can factor one more time. We have the 2, x and x give me x squared. 2 times 2 gives me 4. One of them is going to be plus, one of them is going to be minus. Okay, now the 2 you don't have to set equal to 0 because there's no x to solve for. But the x plus 2 we can set equal to 0, and the x minus 2 we set equal to 0, and we solve. So minus 2, x equals negative 2. Plus 2, x equals positive 2. Okay, so that's where your two vertical asymptotes are. Those are the two imaginary lines that your graph follows, but it does not cross. It avoids them. Okay, so then that leaves your domain to be from negative infinity to negative 2. You're going to see your graph. Then you're going to have your little asymptote, that little gap, and then it's going to continue between negative 2 and positive 2. Then you're going to have a little gap, and then it's going to go from 2 all the way to infinity. And that's it. Thank you guys. We'll see you next time. Bye.